Video is called Back to Basics. Trying to figure out why this and that do not produce the results that I want. So it is back to basics. I'm getting way distracted with real work. I'm doing math. So I'm watching these old videos here. I believe this is like season 2, where I had this green cell like sitting outside of my window, and I was experimenting with these certain components.
Extremely hot going to the pot. So it's actually
This guy right here.
Back loop.
And I have this feedback loop going from the negative of this inductor here, rolling back to the positive end of the other inductor. This is after the primary injects, whatever. And I'm showing 27 volts at the cell?
Of some sort, but I'm able to get...
Too bad I don't have a probe on this or a oscilloscope.
With these
Let's
series of extreme production. That's just...
I mean, look at that production. That's impressive.
Absolutely double point.
Alright, so here, I want to point out here.
Consumed power.
If I'm not mistaken, I'm revert back to my 12 volt adapter in this.
Hour. Alright, final results for the night. I'm back to my 12 volt power supply.
12 volt. I'm back to 12 volts, 1.4 amps. If that amp meter be true. 1.4 amps. That's 17, like I said, 18 watts of power in the video.
Over 27 volts at the cell.
27 volts at the cell? Now if I did that, if I did 27 volts at the cell, and I did 6 cells like I am now, it'd be 162 volts. Now, caveat on this cell was one of the original ones that I made that weren't from a like a manufacturing process of any sort. I don't think the cells are any different, but I do want to order more of these tubes at different diameters and see what they can do. Back on track. Watch me nearly blow myself up here.
And amperage here.
Cool.
Yeah. The only difference is we've got a diode, regular diode there. Got a diode going into the cell. We've got a diode coming out of the cell. And then, interestingly enough, we have a diode connecting the south end of this one with the north end or positive end of that one.
Yep. I'm scrolling. Where did I leave off? And let's just say, and comparatively speaking, if it was 18 watts and we had to multiply that by 6 cells, we'd have 108 watts consumed, which is still way less than what I'm consuming now. What have I been doing with my life? Correction.
These are approximately 358 millihenries. Absolute stellar production.
I'd love to know what that waveform it is pushing out. Hey, looky here, I'm going 900 hertz on this thing. Look at that, 44 volts at the cell. Hold up. 44 volts would be 264 volts on 6 by 6 cells. Holy crap. Theory time. I'm going to try to be as eloquent as possible on this note. Given that the value of the capacitance changes based on whether the cell is energized, and let's say how much energy is in that cell, taking it from microfarads to picofarads, barely 1 picofarad for that matter, there is a sweet spot somewhere between what frequency you're putting into it and the capacitance of that frequency, and that capacitance matched to the inductance for a resonant situation. That would mean that we should only design it for the lowest value capacitance, because that's the voltage level we're trying to achieve, but it affects the frequency. Oh, my brain hurts. Changing the input frequency changes the value. The value is also determined by the energy level of that cell. So we have three variables here that need to come together in these water fuel cells to be at that resonant point where I guess voltage can be maximum for that given cell. But also perhaps resistance as well, because when we go to 10 kilohertz or above, let's say over 2 or 5, the capacitance of the water fuel cell is so low that the resistance is too great for the voltage that you're trying to push into the cell. Wow. I'm gonna have to listen to this again to make sense. I might have to make like a calculator that would do something with this. Oh my god. Okay, I think I'm gonna move on now. I think I have that. Wait, no, I was right. Ha! We're going from microfarads, which is UF as indicated here, to nanofarad to picofarad. We go 3 whole degrees here. So somewhere in the nanofarad range is where the sweet spot is for frequency. 358. We will use that as our baseline. At 100 hertz, I'm in the microfarad range, but nowhere near what the value tested. Like when we're at 1 kilohertz, we should be in the 100 microfarad range, but we're still in the nanofarad range, 70. Well, if we go to 5,000, which is halfway to 10, our capacitance goes to 2.83. Now, given there's more voltage, the reduction of capacitance is probably greater. If we somehow achieve 10,000 hertz, 10 kilohertz, we're down in the picofarad range. But that's not the inductance at 10 kilohertz either. I don't think we have that data. There's just so many variables here, I think it's going to require a system in order to figure something out.
This is Stand Revenge.
Can't tell you how many iterations of this inductor I've made, just trying to get it to stick to the platform correctly, because the each individual bobbin there, I guess you could say, is so small. There's very little to apply or adhere to the print bed. So I designed it a little different, designed a little different, but also increased the initial layer height to about 0.4 millimeters, and it seems to be sticking pretty good. We'll see how it goes. These are basically going to mimic my original, let's say, red coil inductors that gave me the great performance that I had previously. So we're gonna continue this here. It's the back to basics principle here. I'll let you know how it goes. Good lord, the last one also completely failed. It came off the bed entirely, so I made these giant pads on the end to it to hopefully adhere it to the base so it doesn't peel off of there. About halfway done, fingers crossed. Man, this has been a project. Finally, a completed bobbin. It works slow trimming, and I'll be set to go. Let's see if the primary and secondary will print now. Computer crashed, so I have to reload. Not quite the tolerance I want, but acceptable. And now for the next part. Into my bamboo. I got this thing exported, sending to the printer. Layers look good. Now printing, we'll see how it goes. It turned out better than I expected. That's a mighty fine bobbin, a little shaving right there, and be good. Well, what do we have here? The prophecy has been fulfilled. Oh man, we're gonna be close. We're down to the wire, literally speaking. No flipping way. Just enough to get this coil done. But bad news is I have a whole nother coil to wind, so I've got to order some wire. This is my 2025 E-Core, what I'm calling the Fat Boy inductor. I took these, which are kind of what I originally designed for it. Still might wind those up, but wanted these to more closely mimic the physical properties of these. So the circumference is about the same. I think it was, I don't know what the heck it was. Alright, so my original red coil had 30 wraps per coil, about a 30 millimeter diameter, and 14 stacked coils. This one has a few more stacked coils, but also has 50 wraps per coil. So we're going to start off with this one. This one started with 100. That may be a bit egregious. So we're going to start with this one, see what we get, and kind of go from there. Also, I've got these 3 taps on it for a, quote, variable inductor for the inductor B. Pseudoscience is a heck of a lot of work. You know that? Pseudoscience. Lucky for me, I designed machines that make it faster and more efficient, and program machine code to make it work, and do calculations I can in my head, nearing completion.
This is Stand Revenge.